I'm Charlotte. You're watching The Ugly Atheist, and today I wish to discuss life on other planets. When I was little, the kinds of aliens I grew up with were like these. As you can see, they're cute, cuddly, and um, personable, with at least with in the case of ET, there's a wide range of um, expressions, facial expressions. And the generations before me had aliens that looked like these. Now, when I was little, I looked at some of those kinds of aliens from past generations and from my own generation, and I thought, these they look way too human, at least the ones from Star Trek and stuff like that. I thought there was either a lack of imagination from the show producers end, or they just didn't have the budget, or it was too difficult to create really wild looking alien creatures that would interact in a meaningful way with the storyline and engage with the audience. So I was largely disappointed in the kinds of aliens. When ET came along, I thought that's probably closer to what aliens would really look like. But even that, I thought was too cutesy. But then I started doing a little bit more research about how, well, that was when I was a kid, but when I was an adult, I was kind of looking more into the natural history of the emergence of life on this planet. And it seems to me that life on other planets, I think, is a very, very common phenomenon. We haven't found extraterrestrial life yet in our own solar system, but given the odds and given how our the acids and bases that make up our DNA and RNA, self-replicating molecules, are so ubiquitous, and they're found on comets, they're found all over our solar system and in outer space, that I think life itself is probably pretty common. If we I think it would be a safe assumption to conclude that there's probably life all over the universe, all over our galaxy, but intelligent life, I think, is where we run to the uh, a more improbable proposition. And the reason I say that is because if we use our own planet as sort of a really rough guideline for what we might expect to find on other planets, we can see that most of the life on this planet are in the form of bacteria, perhaps some multi-celled organisms, and insects, arthropods, and certainly plants, fungus, fungi. Um, but the more intelligent, the more we go up the scale of intelligence, the fewer and fewer species occupy those positions. And most of them seem to end with the intelligence level of, let's say, wolves or crows or primates. But only one species has reached the point to which we develop a system of language that uh, isn't comprised of mere gestures, but written language that where we can transfer information um, across time and distance, and we have an understanding of engineering and physics to the point where we can actually leave the planet and visit neighboring celestial bodies. So that's only happened once that we know of on Earth. Out of all of the hundreds of thousands, if not millions, of life forms we have, and the billions of years in which there was to evolve, we've only had one species get to that point where we can leave the planet. So, um, if we look for intelligent life on other planets, there's a very high likelihood that they will appear humanoid in more respects than we would probably assume. And I will explain why I believe that. So, looking at our own evolution, the things that propelled hominids into a completely different sphere of intelligence than our um, closest uh, animal and mammal relatives is that we were able to first master we mastered fire, which is, I think that was the golden ticket to catapulting us into intelligence that would inevitably lead us to leave the planet. Um, because fire not only gave us mastery over our predators, so it helped to remove us to a degree from the food chain, where we could protect our tribes, our families, our clans, from the elements and from predators by using fire. But more importantly, I mean, well, equally as important, we used it to cook our food. And what cooking food does is that it takes care of like 80% of our digestion. So, with the vast majority of our digestive process already taken care of by cooking the food, that leaves a ton more energy available for us to use. And that energy seemed to be focused in brain development. So, and they've done an experiment that I remember reading about years ago with rats, where they had two groups of rats. One they gave raw food to, and one they cooked all the vegetables and food that they gave to the rats. And the rats that were given the raw food, they spent a lot of time just lounging around after they ate, just to digest the food. All the energy, they would sleep. All the energy would go towards the digestive process. Whereas the rats that were given the cooked food, they were just energetic. They were running all over their cage. They were playing. They were engaged in other activities and solving puzzles, and that's a remarkable discovery. I'm sure other experiments since then have probably confirmed a lot of that. Um, so mastery of fire is probably, like I mentioned, our golden ticket. And the reason we probably will have a hard time finding intelligent life on other planets is because uh, as soon as a species gets smart enough, like, so let's say to the level of a chimpanzee, and if the planet they're on has either too much oxygen or not enough, then fire wouldn't actually be possible. So they wouldn't have that golden ticket to the next step, the next level of intelligence, evolution and intelligence. And if we take a step farther back in our own human evolution, if we have um, the only way we were able to gain control of fire is that we needed the use of our hands. Our hands needed to be completely free, not used to brachiate and not used to um, ambulate on knuckle walking or anything to that nature. That our hands had to be free to manipulate tools, which means we had to develop upright posture and upright walking. Um, so every step in our evolution was incremental, and walking upright to free our hands up enabled us to master tool making and fire. And mastering tool making and fire, well, I guess first, yeah, okay. There's a lot more to go and do about this. We necessarily had to be bilaterally symmetrical so that we had stereo vision and we had two hands with which to hold something in front of us and to study it, to look at it. So I think if we find intelligent life on other planets, it's going to necessarily need to be bilaterally symmetrical. And it's going to need to have stereo vision, and it's going to need to have mastered fire on its planet. And it's all of these things are going to automatically put it in the phenotypical category of being humanoid, with two legs or some semblance of an ability to walk upright, some bilateral symmetry, the ability to manipulate objects. So it would need to have things that resemble hands or that function like hands. Um, and it would necessarily need to have had some way to have launched it into that next level of evolution. For us, it was fire, the mastery of fire. But on another planet, I don't know what that would be if not fire. Um, so what I'm trying to say is that if a planet would have to be very, very Earth-like in its atmosphere, at least, to be able to have a species that could become intelligent enough to create to understand the physics and engineering required to leave the planet and to send electronic signals and radio waves and gamma rays and whatever communication rays we use to out into space to try to reach out. Um, I saw an alien movie recently that was, I don't remember what the name of the movie was, but the aliens were aquatic. They arrived on our planet. They looked like cephalopods, or some kind of octopus type thing with these long tentacles. They did not have, and their writing looked like coffee stains. I don't know if you know what movie I'm talking about. Yeah, it's like circular writing with splotches. But that an alien that looked like that, I don't think would have reached the level of intelligence needed to leave their planet, especially if they're aquatic. There's uh, too many uh, assumptions that need to be made, like they would not have been able to master their environment other than perhaps being an apex predator, but that is not all your evolutionary energy is aimed toward at that point toward um, being faster and stronger than your prey, um, not toward uh, using fire to your advantage or to make tools. I don't think something like that would have ever gotten to the point where they could leave the planet. So it turns out that the aliens that we see in the old movies that look like humans, like Spock, those might actually be closer to what we would find if we found intelligent life on other planets, um, than we would some other crazy looking creature like from the movie Aliens or something. Well, that wasn't an intelligent alien. That was just a predator of some kind. So, um, yeah, I guess the reason I wanted to delve into this is just I find it interesting, and I hope we keep exploring space, and I hope we someday do find aliens. Do I think aliens are here now? I don't. But I know a lot of people do, and if aliens were here and they're as elusive as people say, that would make sense, I guess, in some level. Like if they're here to study us, then they would want to be as undetectable as possible, I would imagine. But um, it's hard to say. It's hard to say because all of the reports of aliens that people have submitted lar- are largely contradictory, and the type of crafts are all different, and they all kind of mimic the old Hollywood movies of spinning discs and that kind of thing. So I don't know. I'm doubtful. I don't believe that aliens are here or have found us or are studying us, but I'm certainly open to the idea that I could be wrong. So um, we'll just leave it there. And I'm Charlotte. You're watching The Ugly Atheist. I hope you enjoy this kind of content. And if you do, please like and subscribe. And I hope wish you and your family a happy new year. And we'll see you, I guess, in January.